Hello, I welcome you all to this another interesting screencast. In this particular problem, we have a 150 pounds skier, and at point A, he has a speed of 5 feet per second. We are being asked to determine his speed when he reaches point B on the smooth slope. By this, we mean, I know you know already, no friction. Okay, so this will mean no friction, right? For this distance, the slope follows the cosine curve shown. Also, what is the normal force on his skis at B and his rate of increase in speed? So this rate of increase is the acceleration. Neglect friction and air resistance. So we are going to combine a lot of principles in working on this particular problem. We are going to use the principle of work and energy to find the velocity or the speed at B. We are going to use the coordinates n and t axis, and later on apply the equations of motion in both the n and the t axis to find the rate of increase or the acceleration at, as well as to find the normal force. Of course, we need the angle, right? And that angle, we just need to take the derivative of y with respect to x. So all those particular steps, we are going to apply them in this particular problem. Let's start with drawing the free body diagram. We have the weight of the skier acting through its center of gravity. Then we have the normal force, like so. Okay. And then let's say we extend this axis like so. Let me use this color. I prefer this one for really no particular reason. And then I extend this one like so. I want to call this as my n-axis. Like I said, I'll use this, and then let me call this one here as my t-axis or tangential axis. Alright. What else? Then I'll have component of the weight. I'll have components of the weight in this direction. Okay. As well as this direction. Alright. So I'll have another component in that direction like so. Alright. What else? I think this is about it. And then I think the other part, let me show the angle. We do have the angle somewhere there like so. So we have the angle here. Let's call this one as theta. So if this is theta, this becomes 90 minus theta. Sorry. This becomes 90 minus theta, then this one theta, right? Okay, so this one is theta, right? This is W, and therefore this just becomes W cos theta, which is the weight W sine theta. Alright, so we said this is our tangential axis, this is our normal axis, and this one is the normal force. Great. So let's find this theta. So let's say we do have our y, which is as equal to 50 cos pi, like so. Then I'll just say let alpha maybe be equal to pi over 100 x. Then I can simply say my y prime is just going to be equal to my y, therefore is just going to be equal to, I can write y as equal to 50 cos alpha. Okay, so y prime, which is just equal to d dy dx. We are going to use the chain rule. This just becomes dy the alpha, then by the alpha dx. Okay, is that okay? So if we did so, therefore our y prime just becomes equal to divide the alpha, we have a minus 50 sine alpha, and then we do have just pi over 100. So y prime will just be equal to minus 50 cancels there, so we just have a pi over 2 sine alpha sine alpha. But let's work out what alpha is in degrees. I prefer it in degrees. Again, you don't have to work it in degrees if you don't want to. You can still work it out in radians. Just make sure you change your calculator when you're working out this sine or cos. So I'll say my alpha, we said, is equal to pi divided by 100 at x by x, and our x here is equal to 35. Seen here is 35 feet, and therefore my alpha will just be equal to this, and then by 35. Okay, then we know that 180 degrees is equal to 1 radian. Okay, just 1 radian. We just put pi there. Alright, and then this and this goes. Therefore my alpha, if you worked out alpha here, so 35 by 180 divided by 100, this we have a 63 degrees. So there we go. So this angle tan, so we know that tan theta here is just equal to y prime, and this is equal to minus 50 sine minus, we evaluated this, minus pi over 2 sine alpha, which is just 63 degrees. Remember this equation. Therefore, making theta subject to the formula, which you can do. So we are going to have minus pi divided by 2 times 63. Then tan inverse of that, we have a minus 54.45 degrees. Again, when you look at this minus, it just shows that we are moving clockwise, right, from that reference, you see. So we can write this as just theta is equal to just 54.45 like so. Okay, great. So we have this. Let's now apply the kinetic the work and energy principle. So the kinetic energy at A plus the total work from A to B is just equal to the final kinetic energy at B. So I'll need this distance here, this one here. Okay, I'll need this distance here. So let's call this as our HA. Okay, and this HA is just going to be equal to y at 0 minus y at 35. Okay, work out that later on. So the initial kinetic energy half times m va squared, and we do have the work done by the weight from A to B. We have the weight, the displacement in the same direction, therefore this is positive work. So this we are going to say plus W times HA This is equal to half mvb squared. Our HA, let's find our HA, our Y at 0 is 50, okay, and our Y at 35 feet is equal to, because this point here is 0, okay, this point here is 0, 0, okay. 35, we do have Y, that's 50 cos 63, that's what we said. So that one just becomes 50 cos 63 degrees, and this is just equal to 22.70, and therefore our HA is just equal to 50 minus 22.70, and this gives us this one gives us 27.30 feet. Okay, like so, 30 feet. All right, so we have this one. So what we need to do now is to feed all those inputs in there. So we have 150 divided by 32.2, then times VA, which is just a 5 squared, in plus we have W, okay, we do have W. Our W is 150, okay, times HM, 27.3, and this is equal to half. M again is just 150 divided by 32.2, then times VB square. Alright, so let's create some space here. Let's create some space. Okay, there we go. So making VB subject to the formula, our VB just becomes equal to 0.5 by 150 divided by 32.2 by 5 squared plus 150 by 27.3 divided by 0.5 by 150, 32.2, square root of that. Of course, this gives us a 42.23 feet per second. So 0.5 by 150 divided by 32.2, I squared plus 150 by 27.3 divided by 0.5 by 150, 2.2, square root of that. Yeah, so that's our VB. Okay, so we know that our VT is just equal to VB. Okay. Alright, so once we found this, we can find the normal force, right? We can find the normal force, we can find the acceleration. So for the normal force, we require rho, and our rho is just equal to 1 plus y prime, and this is squared, and then this one to the power 1.5, then divided by y double prime. Okay, so y prime at 63 degrees is just equal to so minus pi divided by 2, okay, times sine 63. So this we get a minus 1.3996. So we are using this equation here. Then let's find y double prime. So y double prime is just equal to, this just becomes pi, okay, over 2 cos pi, cos alpha, okay, then times again the alpha dx. So this again we have just pi over 100. So this just becomes equal to minus pi squared divided by 200 cos alpha. Alright, and then y double prime at 60 degrees, this is just going to be equal to minus pi divided by 200, minus pi squared divided by 200 times cos 63. So this we get a minus 0.02240. So this we always use a modulus or absolute value. Okay, absolute value. All right. Okay, so fitting all those values in there, so we'll have 1 plus minus 1.3996 squared. Okay, then we work out this to the power 1.5, then divided by divided by 0.02240. This will get 1.3996 squared, okay, plus 1 square root of 1.5 divided by, like so. So this we get a 227.22 feet. So we have this, then we can apply the summation of forces in the n direction, and this is just equal to m a n. All right, so we do have motion in this direction, like so, motion in that direction. This is our AT, this is our AN, and our AN is just equal to VT squared divided by rho, rho being the radius of curvature. And then this just becomes W cos theta minus N equal to M, then VT squared divided by rho. And our N is just equal to W cos theta minus MVT squared divided by rho, and this is equal to 150 cos 54 point, what was our theta, 45 minus 150 divided by 32.2, and then we have our VB, which is just a 42.23 squared divided by 227.22. All right, and then our n therefore will just be equal to so we have, let me just move this a little bit backwards, like so. All right, so our n therefore we have 42.23 squared divided by 27 227.22. Okay, then times 150 divided by 32.2. Okay, there we go. Then plus 150 cos 54.45, 54.45. Okay, all right. So this we get n equal to 50.65 pounds. Let's work it out again. 50 cos 54.45, 54.45 minus 150 divided by 32.2 times 42.23 squared divided by 227.22, 50.65. So found the value of n. Let's find the acceleration. So just say summation of forces in the t-axis just equal to mat. Okay, then we do have w sine theta is just equal to mat, and our at is just equal to w sine theta divided by m, right? And at is just going to be equal to 150 sine 54.45 degrees divided by m, which is just 150 divided by 32.2. So we can cancel out this and this, and then therefore our acceleration just becomes equal to 32.2 sine 54.45. Okay, so this just becomes a 26.20 feet per second squared. Oh, I guess we are done. So we do have our velocity VB. Okay, so this is our velocity VB. We do have our normal force. Okay, and then we do have the rate of increase in speed. All right, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.